Okay, section 5.4, fitting a line to data. So we've been talking about how to write equations for lines. And in real life, typically when we go out in the real world and take actual data, it usually does not fall in a perfectly straight line. If you remember studying scatter plots back in middle school, that's a little bit more like reality. You're going to get some points in a plane, and they're kind of all over the place, but often you can notice trends. Maybe there's an upward trend, maybe there's a downward trend. And when we have a trend, one thing we like to do is create a line that best represents the trend, and we call this a best fit line. So the goal for tonight's lesson is being able to look at a data set or a scatter plot and figuring out how to not only draw a best fit line, but more importantly, how to write the equation for that best fit line. And basically, we're just going to do one big example together. And if you need to go back over this example, feel free to watch the video as much as you want. All right, so usually when real data is collected, there is no one line that will go through all of the data points. In this case, we try to find a line that best fits the data. We call this a best fit line. Sometimes you'll hear people say line of best fit. Okay, so this will be the data that we are analyzing tonight. And I should go ahead and say, if you don't already have graph paper out, you will need graph paper. So if that's the case, pause now, get graph paper, and then come back and unpause. So what we're looking at is, here's the data of a tadpole's tail length as it turns into a frog. And you're going to see a couple different data points here. They are in no particular order, but we have days on top, so the age of the tadpole in days. And then on the bottom we have the tail length in millimeters. So if you look at that very first set, when the tadpole is 5 days old, he will have a tail length of 14 millimeters. Another point in time, they took another data point. When he was 2 days old, he had a tail length of 15 millimeters. And basically what we're looking at here are some ordered pairs. So what we're going to do is we're going to take this information and we're going to first plot it all as points. We're going to create a scatter plot. But before we can plot anything, we need to set up our graph, our coordinate plane. And I'm going to have you follow along with the one that I did because I want ours to look the same. So on your graph paper, I want you to take a minute and go ahead and set up something that it looks exactly the same. So we're going to have days on the x-axis, and that is our independent variable. And then we're going to have tail length on the y-axis, that is our dependent variable, because we would say that the tail length depends on how old the tadpole is. So that's why the y-axis is always the dependent variable and x-axis is the independent variable. Notice that our coordinate plane is going to skip count by 2 on the x-axis. It will also skip count by 2 on the y-axis. It's important that you do that because I want our scatter plots to look exactly the same. So go ahead and take however much time you need to set this up. I'm going to go ahead and pause the video. You should pause it too, and just unpause when you're ready to plot the points. Okay, hopefully you are ready to go. Before we get started, I'll go back to the data table in a second, but before we get started, let's say, for example, that you needed to plot a point like 21, 3. This is not on your table, but I want to talk about this before you start. So in order to do this, we're going to have to interpolate a little bit, because if you look at your x-axis, there is no 21 there. We have a 20 right here. We would have a 22 right here. And so to interpolate, 21 would be that value. Likewise, on the y-axis, we don't have a 3. We have a 4. We could suppose that 2 would be right there. So 3 would be somewhere in between 2 and 4, exactly halfway in between. And so if you were to plot that value, you would need to interpolate the point. You should be floating somewhere about here. Okay, so just make sure that you interpolate correctly when you go back to plot all of the points. All right, so I'm going to go backwards and show you that table once again. It looks like you're going to have 8 data points, beginning here with 5, 14. And the next one would be 2, 15, and so on and so forth. So I want you to go ahead and plot all 8 of these points, plot them correctly, and when you're done, we will compare scatter plots. So go ahead and hit pause now, and then unpause again when you are ready to compare your scatter plot with mine. Okay, let's see how you did. So your 8 points should look something like this, and they need to be pretty exact here. So if you find that you did your scatter plot incorrectly, I want you to go back and try to find where you made your mistakes and redo it. Otherwise, this is going to make no sense. If you do have the exact same scatter plot, let's talk about this, because the point here is we're trying to draw a line of best fit. First thing I want you to notice, if you had to answer this question, do you think that this is showing a positive trend or a negative trend? In other words, is this going up the roller coaster or down the roller coaster? Hopefully in your mind right now you are saying negative trend. It would be going down the roller coaster. So when we draw a best fit line, we want to accomplish 2 things at the same time. One, we want to model the slope as accurately as possible, or maybe I should say as precisely as possible. So the slope needs to match up. 2, we want to draw the line such that it's kind of the average of the data. I would expect to see maybe some points on top of it and some points below it. There's no way I can draw the line through all of those points. It might not even hit any of them. It's probably going to run into a couple of them, but it wouldn't necessarily have to. So the line would be expected to be the average of the data as well. Okay, so for example, if I drew this as my best fit line, do you think that that would be a good best fit line? And hopefully you are saying no. Now, what would be the good aspect of this? Because it's not completely wrong. Of those 2 things, it does accomplish one of them. Okay, the one it accomplishes, it does model the slope pretty well. All right, this is definitely going down the roller coaster, and it has about the same steepness. So I like the slope. The problem is it's too far removed from the data points. So that would not be an appropriate best fit line. Okay, let's look at something like this. Okay, would that be a good best fit line? Hopefully you also said no again. Okay, now this time kind of the reverse is true. It does go through some sort of middle of the points, all right? It's got, points off here to the left. It's got points off here to the right. It kind of goes halfway in between those, so to speak. But do you think the slope is appropriate? I don't. Even though it happens to be going down, I think it's too steep. Both of these would be steep lines, but this one's way too steep. So I think the slope is kind of funny. It's off. So also not a good best fit line. All right, hopefully, and before I go ahead and show you this, if you haven't drawn one yourself, go ahead and draw what you think the best fit line should be. All right, so hopefully your best fit line looks something like this. And you're going to notice that this accomplishes both things at the same time. We've got an appropriate slope, and also this line represents the average of the data. You're going to see some points on top, some points below, but basically this line runs right through the middle, and it approximates the right slope. Okay, so we've got a good best fit line. If your best fit line looks like mine, let's continue. If not, you need to redraw it so it does. All right, so the big goal, we need to write an equation for this line. Okay, and you've already had some practice writing equations. So if you want, let's begin by writing down y equals mx plus b. You know that to write the equation for a line, we're going to want to have a slope, right? And we're going to want to have a y-intercept. And I want to begin talking about the slope. The slope is the important thing to begin with here. Okay? To get the slope, we are going to pick 2 points. And I'm not talking about points that we've already plotted. Like when we made the scatter plot, you don't need to choose those points. You might not want to choose any of those points. And the reason is, like, for example, if you're looking at this dot right here, okay, you say, oh, I'm going to pick that point, it's on the line. Well, what would be the coordinates of that point? I mean, you're really going to have to interpolate to write down some coordinates here. It doesn't even look like 6, it looks more like 5.9. It's somewhere in between 8 and 10, favoring, you know, the 10 a little bit. So maybe it's like 5.9 comma 9.2. I don't know about you, but those are numbers that I don't want to work with. So we want to choose points that are on the best fit line, but that also would be whole number coordinates. And what I mean by that is we are looking for things that would meet at blue corners. If you look at your graph paper right now, okay, notice how I am coloring in blue corners. Blue corners are where whole numbers meet whole numbers. So take a look at, take a look at the graph that we've developed here. Does it cross over any blue corners as it descends? Okay. So I want you to see if you can find a point or two where it crosses a blue corner. Those are going to be the ones that you want to use. If you find a blue corner, go ahead and color it in. Here's my first one. See how our graph crosses right at a nice whole number corner. Okay, now what point is that? Well, that's 4, 12. That's going to be one of my 2 points. What do you think my other point will be? I'll give you a hint. If you haven't found it, I'm heading this way down my graph. All right, hopefully you see it now, but right here crosses at a blue corner. Okay, what point is that? Well, that's 8, 6. Why am I trying to find 2 points? Well, go back to the very last lesson. Anytime you have 2 points, you can write the equation for the line. We're going to use those 2 points to find the slope. Okay, so let's begin with the slope. Go ahead and take those 2 points and plug them into the slope formula. And I want you to get a head start on me. Okay, so go ahead and take those 2 points, plug them into the slope formula, and see what you come up with for slope. And when you get there, feel free to hit pause. Or I guess I said that backwards. You can hit pause now, and then we'll go ahead and do this together. Hopefully you're already on it. I'm going to go ahead and hop in, write down my slope formula. So I know that m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, the change in the y's over the change in the x's. And like you've probably seen me do in class by now, I always like to draw in my minus signs. They help me with the formula. I don't get as confused with negatives. All right, so y sub 2, and these can really go in any kind of order. For me, my y sub 2 would be 6, and my y sub 1 would be 12, and my x sub 2 would be 8, and my x sub 1 would be 4. And as I crunch those numbers, I'm going to get a negative 6 on top and a positive 4 on the bottom. If you did it the other way, you might get a positive 6 on top and a negative 4 on the bottom. And then I need to reduce that. So negative 6/4 reduces to negative 3/2. So that is my slope, negative 3/2. I want to do a quick slope check. Negative means it's going down the roller coaster. That's a good check because my line is definitely going down. 3/2 implies that it's kind of steep, and it is kind of steep, so I like it. All right, so remember, right now, here's what I know. I know that y equals negative 3/2 x plus b. And I need to figure out what that y-intercept is. And I know that you could look at the graph. Don't look at the graph. I want you to do it algebraically. The algebra is here is what we're here to practice, and we can always check it graphically, and hopefully the two will match up. So remember, I'm going to plug in an x value, and I'm going to plug in a y value. And you can choose either point. I'm going to choose the 8, 6. So if you want to get a quick head start on me, I'll give you a 15-second head start. Okay, remember I'm plugging in 6 for y, so I got 6 equals -3/2 times x, and my x value is 8 for that particular point. Once again, I'm using this point right down here. You could use the other point if you want. And it's going to be that plus b. So now I just need to crunch the numbers. So it looks like 6 equals -24/2 plus b, and that's 6 equals -12 plus b. And then remember, I'm trying to isolate b, so I add 12 to both sides. And that gives me 18 equals b. Okay, so I'm going to take both of these numbers and write my equation. So final equation in slope-intercept form: y equals -3/2 x plus 18. And I can double check that. We already double checked the slope. The slope looked good. Negative going down the roller coaster, steep, that matched up. But let's also check the y-intercept, the 18. So if I look at my graph, it crosses the y-axis right there. And what number would that be? That looks exactly like 18. So the algebra backs up the graphic, and that's always a good thing. So when that happens, you can rest assured that you are probably correct. Okay, so really quickly, if that didn't make sense to you, I'll do a quick review of just any time you want to draw a best fit line, okay, and you want to do so, so that it approximates the slope and it's also the average of the points. Once you do that, here's how you write the equation. Grab any 2 points on the line, but pick good points, ones that are going to be whole numbers. Okay, from those points, you use the slope formula and you find the slope. Okay. So like we did with 8, 6 and 4, 12, we plugged these into the slope formula, and we found that the slope was -3/2. Once you know your slope, use your slope and an x value and a y value and plug it into y equals mx plus b. Then you just crunch the numbers, work backwards to figure out what b is. In our case, it was 18. You got both pieces of information, just put them together and you have your equation. So that'll be what you're doing mostly for this assignment. So good job with that. Some vocabulary points really quickly before we go. When you have a best fit line, and that the best fit line is going up the roller coaster, okay, we say that that has a positive correlation. In other words, x and y have a positive correlation. So basically, if you can draw a best fit line and it has a positive slope, we will refer to that as positive correlation. If you draw a best fit line and it's going down the roller coaster, it has negative slope, we will call that a negative correlation. X and y have a negative correlation. In the example we just did, x and y had a negative correlation. There are times, however, that when you create a scatter plot, it's difficult to draw a best fit line because you're not sure what the trend is. And that's okay, that happens. Sometimes there's not really a trend. And so when you can't even make a best fit line, we say that the quantities x and y have relatively no correlation, or you can just say no correlation. And here are some graphics for that. So that one should make sense, that one should make sense. And here would be an example of something that has no correlation. So if you had to draw best fit lines, it would be pretty easy to do for the first two. Okay, number one is definitely going up the roller coaster. You'd probably draw something like this, right in the middle of all that data and showing that the slope is going up. And the second one, maybe a best fit line like that. Mine wasn't perfect. Maybe move it down a little bit, but the point is it's definitely going down the roller coaster. It's got a negative correlation. On the third one, I have a hard time drawing a best fit line. I mean, part of me wants to do this, put it kind of in the middle of the data there, but then at the same time, part of me maybe wants to do this, and I'm not really quite sure, right? So when you're not quite sure, if you're questioning it, it probably has no apparent correlation, and you can say no correlation. All right, pretty easy stuff. Feel free to go back through the video if you need to review the process of writing the equation, but it is a pretty important real-life application, and we're going to be using this a lot tomorrow in class, so practice up. All right, thank you guys, and good luck on the assignment.